The objective of this lesson is to model division of a unit fraction by a non-zero whole number in a partitive division context. Let's begin with the problem. 1/2 of a box of jelly beans fits in 5 small containers. How much of the box fits in 1 container? Let's use Cuisenaire rods to model the problem. Start by placing an orange rod to represent the whole box of jelly beans. Write 1 whole box. Next, place a yellow rod to represent 1/2 of the box. The yellow rod works because it takes 2 yellow rods to equal 1 orange rod. Next, divide the 1/2 box, or the yellow rod, into 5 equal containers using white rods. The question is asking how much of the whole box fits in 1 container. There are 5 white rods in 1/2 of the box. In order to represent the other half of the box, another set of 5 white rods, or 5 containers, will need to be laid out. There are 10 of the white rods, or containers, in the whole box. Each white rod, or each container, fits 1/10 of the whole box. The equation to represent this problem is 1/2 divided by 5 equals 1/10. In other words, 1/2 is 5 groups of 1/10. 1/2 is an equivalent fraction to 5/10. Let's model another problem. 1/3 of a box of jelly beans fits in 5 small containers. How much of the box of jelly beans fits in 1 small container? Let's use Cuisenaire rods again to model the problem. 1 orange rod this time represents 1/3 of a whole box of jelly beans, so 3 orange rods would represent 1 whole box of jelly beans. The 1/3 of a box fits in 5 small containers, so partition 1 of the orange rods into 5 equal pieces. This can be shown using 5 red rods. The question wants to know how much of the whole box is in 1 of the containers, or 1 of the red rods. This can be modeled by laying out 5 containers under each 1/3 size orange rod, for a total of 15 red rods, or 15 containers. Each red rod, or each container, can fit 1/15 of the whole box. The dividend 1/3 is represented with just 1 of the orange rods. The divisor 5 is represented with 5 red rods. The quotient 1/15 is represented as 1 of the red rods, as compared to the whole box of jelly beans. The related multiplication equation would be 1/3 is 5 groups of 1/15. The dividend represents the divisor amount of the unknown measure. Another way to solve would be to multiply the dividend by the inverse of the divisor. 1/3 times 1/5 equals 1/15. Although students may be able to solve these division problems without using a drawing, they should be challenged to do so. Let's model and solve one more problem. 1/4 of a cake fits in 4 small containers. How much of the cake fits in 1 container? The equation to solve the problem is 1/4 divided by 4 equals A. Start by drawing a rectangle to represent the whole cake. The problem states 1/4 of a cake fits in 4 small containers. To model the 1/4 cake, divide the rectangle into fourths. This 1/4 section can fit into 4 containers. Model this step by drawing a rectangle below the 1/4 section and divide the rectangle into fourths to show the 4 containers. In order to find out how many containers are needed to fit the whole cake, duplicate the bottom rectangle 3 more times until it matches with the whole cake. There are a total of 16 containers, so 1 container fits 1/16 of the whole cake. The related multiplication problem would be 4 groups of 1/16 equals 1/4. The objective for this lesson was to model division of a unit fraction by a non-zero whole number in a partitive division context. We met this objective by modeling real-world partitive division problems using Cuisenaire rods, as well as the invert and multiply strategy. We related the parts of the division problem to the model, as well as created a related multiplication problem.